So thanks for joining us. There's all this talk out there about measurement-informed inventories. Many people are saying it. And I think it's generally accepted that the old traditional static emission factors really were pretty inadequate. And I think measurement-informed inventories are a way to compare measurements taken by continuous monitoring, flyovers, satellites, what have you, and compare those to the estimates to say, how can we refine those estimates? And I think this is really important because it informs capital allocation, right? Where you're going to spend money to get the most bang for your buck. It also helps inform statistical sampling. How many of these facilities do I need to perform these measurements on? And how frequently do I need to perform those? All in an effort to put forward a more complete depiction of a company's emissions for their investors, for the regulators, or the population writ large. So excited to dive in a little bit more and pick apart some of these pieces.
I think first it's important to define, in fact, what measurement is. And so measurement is the use of advanced technologies to look at emissions performance over a variety of time and spatial scales. And so there's lots of technology available, and your choice ultimately is going to define how you compare those bottom-up calculations, which we know to be deficient, to the measurements that you're actually taking. And then you need to ultimately reconcile those numbers. And that is really the process to get there, I think, is what requires a lot of trial and error to ultimately get to a true prescriptive definition. And there are a lot of regulatory and voluntary protocols that have come out in the market to try to ultimately shape what a measurement-informed inventory will look like. So a couple of indicative approaches would be OGMP 2.0. They use bottom-up calculations and then site-level measurement, and then they have an investigative component. So you need to go out and look at that particular period of time where you were doing measurement, compare it to those estimates, and then try to reconcile those two, doing in-field reconciliation. You have GTI Veritas, which actually focuses more on best calculated, best measured. Those two things can be used in tandem. And then you have Colorado regulation that's moving in this direction, and they are looking for operators to start putting forward solutions to try to identify what the right approach is, with the understanding that there's likely not just one right answer.
How would you describe measurement-informed inventories?
I think it's important to first focus on what is measurement. And so measurement is meant to be the use of advanced technology to measure methane emissions. That can be either through continuous monitoring technology. So that means that you are going to be measuring methane for every minute of every day, or you're looking at more intermittent solutions. This can be flyovers, this can be satellite. And that is going to be a point in time measurement of emissions that are occurring on a particular site. Now, measurement also comes with different capabilities. And so you're looking at, minimum detection thresholds. Say, continuous monitoring can range from, below the atmospheric concentration of methane to slightly above your baseline emissions. Whereas typically the more intermittent solutions are going to have a higher minimum detection threshold. And that's going to impact ultimately how you reconcile between measurement and those bottom-up calculations. So we focus on the measurement component. Now, when you talk about a measurement-informed inventory, the inventory is those calculations that you spoke about. They are the generally understood to be deficient calculations that are done for regulatory purposes. And then measurement is the advanced technology. You have to compare those two values over the appropriate time scale, and then ultimately come to a single number that is more accurate than one of those numbers in a vacuum.
Yeah, it's funny you say that, because this is a question I think that we get all the time, right? Like, what is a measurement? And in essence, it can be nearly anything. Is that how you mean? It could be like parametric data from tanks there on the site. It could be a satellite flying over. It could be a plane. Do you think I'm thinking about it too broadly?
I don't think that you're actually thinking about it too broadly in the sense of the definition of a measurement. I do think you are thinking about it too broadly as it relates to the definition of measurement for a measurement-informed inventory. Because ultimately, you can make the argument that those calculations you spoke about, so using GHGRP calculations, is a form of measurement because it is using emission factors that were based on measurement. Now they are deemed to be outdated and maybe not representative, but they are measurement. So when you're talking about a measurement-informed inventory, talking specifically about the use of advanced technologies, and even more importantly, capable of doing that site level measurement. So you can compare both at the site and then ideally at the source level, what those bottom-up calculations result in compared to the methane measurement technology.
We'll get back into this point about parametric data with an example in a moment, but I guess, how do you think about this? Because there's really the measurement in space and measurement in time. So like aerial flyovers, they can sample a wide geographical area. They can see all sorts of emission sources, but that's only for a very short period of time, seconds oftentimes. And then you have continuous monitoring, right? Where it's trying to measure around the clock. Obviously, ambient condition dependent. Is the wind blowing in the right direction in many of these cases, but it's limited to one site. And so how do you start thinking about this as it relates to measurement?
So there's obvious advantages to using continuous monitoring technology as it relates to comparing to your bottom-up calculations, because you're going to get such a broader set of information to compare to those calculations over a very long period of time. But to your point, the disadvantage that you have is that you can put continuous monitors on one site for a deep level of understanding, whereas if you were doing flyover, for example, you can cover multiple sites over a much shorter period of time. And so the way that I think the best way to think about this is actually mixing the use of those technologies. So continuous monitoring can help you understand at a deep level the characteristics of a type of site. And this is where you start to think about the concept of statistical sampling, because you do need to understand at a deeper level what's happening on these facilities, but how can you select sites in a statistically representative way to then ultimately drive learnings across those sites where you're maybe leveraging more intermittent technology.
That's a great segue, because oftentimes this topic will come up on statistical sampling. What is enough statistical sampling?
It will continue to be a question. So really what I always say is it's best to get started. So one of the approaches that we typically put forward is to look at the vintage class of sites and also the design of those sites. Why? Because equipment is a large driver, and equipment selection is a large driver of emissions performance. And the age of your asset is also going to be a driver of emissions, because technology evolves over time, designs evolve over time. And so that's a great opportunity for you to look at the variability across your assets, put forward a monitoring strategy, and then select sites so that you are looking at a variety of sites to start, so you can actually change that strategy over time as you learn more. What we do know is that the emissions distribution that is understood to be true under GHGRP is in fact inaccurate. And so it's important to start looking across a diverse set of assets to then understand, what does that true emissions distribution look like?
Yeah, I always try to nudge people, like the greater diversity that you have in any underlying population, whether that's people or whether that's pieces of equipment or well sites or whatever it is, the greater sampling often that you need to characterize that population. So if you have a whole bunch of the exact same wellbores constructed the exact same way in the exact same year, going after the exact same formation, managed by the exact same company, probably slightly less sampling is needed than a multi-basin operator with all sorts of assets that were acquired from multiple entities over a long period of time, managed by different business units, right? And so these are the ways that oftentimes I try to just push people to relate it back to oftentimes people or polling or things like that. And so as you've thought about this idea of sampling more, what you're effectively saying, and I think some people have a hard time with this, is maybe you will be using pretty heavy measurement, expensive measurement on sites that may not be able to support that. How would you be able to justify that to an operator who's trying to watch their bottom line quite closely?
That is very, very fair. I do think that it is worth thinking about this problem a little bit differently, because ultimately what you're doing is you're driving for education on your assets across all assets. So you can actually take some of those higher producing and therefore more lucrative sites, you can not invest in that continuous monitoring technology there, and then that offsets the cost on maybe some of those lower producing assets, and you're going to be learning across the full asset base. So you're getting scale in that investment in ways that you wouldn't if you just focused on those higher producing assets, where you are ultimately making more money and therefore have higher margins.
Yeah, I always say, like, if you have 800 low flow wells that look pretty similar, measure on 30 so you don't have to measure on the other 770, right? It could be helpful. I don't think people understand, though, the ramifications of this measurement informed inventory data, right? And one of them is the allocation of capital. So obviously we were working with a client. They were swapping out their pneumatics. We were using continuous emissions monitoring on these sites. And what they saw was that the emissions reduction. They were expecting a 75% reduction, but really what we quantified was a 75% reduction in emissions. They were not exactly happy. But the interesting part is when the refined intermittent bleed EPA estimates, at least were proposed, it dropped from 13.5 to 8.8. And the point is that this was helpful for this operator to understand that, because rather than just plow ahead with their pneumatic retrofit, they started paying more attention to the types of pneumatic devices that they swap out, right? Intermittent bleed, high bleed, low bleed, whatever they are, and where on the facility they're actually designed. So is it emergency shut-in pneumatic, or is it, a pneumatic that's often utilized throughout the operations of the facility? As you've started to see some of the data roll in, where are other areas where you have found kind of a large gap between what operators have been expecting to see emissions reduction, either high or low? What are you seeing out there?
So pneumatics is really a great example, but another example would be tanks, which I think also brings us back to your comment on parametric monitoring. Mm-hmm. That also might be an opportunity to leverage both monitoring data with the operational data that might be available for those tanks to start understanding that emissions variability, because that is really what we see when you're looking at those static calculations and comparing them across different equipment groups. You see a very large difference in terms of those simulated tank emissions versus what's actually happening out in the field.
Yeah, I was talking to someone, and she did a lot of these simulations. She's like, well, if the people at HISIS or ProMax are doing them, they're actually pretty close versus an operator who's trying to do 600. And the point that I was going to make when I brought up parametric data before, and you pushed back, was like Nord Stream 2. So like the satellite clearly spotted it. It got a pretty good flux, but like, was that flux stable? They were able to go in and they understood the dimensions of the pipe. They understood the pressure of the pipe. They understood the gas composition of the pipeline. And obviously they understood the exact portion of the pipeline that would have leaked all the methane to the atmosphere. Once they knew that there was a leak, that was closer to best calculated versus best measured. But first they needed to be tipped off. In this case, it was pretty obvious because there's a huge pipeline that was blown up. But my point is the same thing, I think, plays out with tanks now.
I think so, yes. But I think my point is when you talk about a measurement-informed inventory, it's important to take that step with measurement because we don't know the answer yet. So parametric monitoring may be the future for some pieces of equipment. You will maybe have a better understanding of what is best calculated. There is, I think, a disagreement on that in the space because there's not comparison data sets for you to look at. So I agree with the premise that parametric data has a role to play in measurement, but I think you need some data to compare that to actually build out the efficacy of that argument.
Totally agree on that point. I think this also leads into the point about and this came from the great paper that I think we'll talk more at a later time about towards multi-scale measurement-informed inventories by Daniels and others. But which one of these measurements is correct? That's oftentimes what you'll get. And my short answer is neither. And I think that makes people very uncomfortable. I'll just say that. I say this because they all have shortcomings. And so have you seen certain areas where some excel and others have deficiencies?
Well, I think to your point, one or the other isn't necessarily always right. This is actually kind of comes back to the original point I made around investigations. You do need to do some in-field confirmation of what the measured value is telling you versus what the estimated value is telling you. And I think there's certain things like combustion, for example, where you can actually do additional equipment testing and probably have a better understanding of combustion performance on your equipment. That might be best calculated, but there are going to be certain things like methane slip that are going to be much harder for you to understand as it relates to compressors. And so that's where a measurement can actually be very additive. But I'm not sure I fully understood your point. So maybe.
Yeah. So the general point was, do you find that some pieces of technology excel at certain types of measurements and other ones are stronger in other areas?
Oh, well, absolutely. If you think about continuous monitoring is going to be really very, very good at some of those low level emissions. When you're talking about high velocity emissions that are at height, a lot of times you're going to have top down measurements that are going to be better because you're actually able to measure the vertical elements of that emission versus the 2D dimensions that you're typically looking at when you're doing modeling with continuous monitoring. Yeah,
that's something we see all the time. It's a smattering of technologies where some excel and some stuff, even like there's companies that fly drones around the perimeter of a facility, and that's actually pretty dang good for like a total site level flux, at least at a point in time, even better in some ways than some of the top down stuff. But it depends on ambient conditions, obviously. So as you look out, where are you seeing these measurement-informed inventories come into play the most? I know people often talk about OGMP 2.0. There's big news with the new super major that signed up for OGMP 2.0. Like, how much does that play into the equation here?
So I think that you're going to see the largest push coming out of exactly what you're talking about, which is those voluntary markets. There is right now one state that has pulled this into a regulatory framework, but ultimately I expect a lot of this to come through those voluntary protocols. So you have OGMP 2.0, which is going to be focusing on comparing measurement and estimates to then ultimately go out in the field and investigate. You have GTI Veritas, which is actually a more prescriptive method that can feed into OGMP 2.0 or can be treated separately, looking at the best calculated, best measured. I think these types of voluntary approaches are ultimately what's driving adoption, because people want to learn through collective action. Ultimately, it is incredibly helpful for operators to be putting forward solutions, then ultimately driving towards those solutions and sharing those learnings across companies, because there is really no right answer right now. But there are companies like ourselves that ultimately want to help people drive in this direction and leverage the data in the most effective way possible.
Yeah, you mentioned one state that allows us, that state also allows parametric data. So just saying. But to this point, I guess, like, I think a lot of people will see these protocols, OGMP 2.0, Veritas, whatever else will come out, and they say which one of these is correct, which one of them is right. And at the end of the day, it's really just an investigation, right? There is no quote unquote correct protocol. And I think that's what a lot of people are craving for, is they just tell me what to do and I'll follow this playbook. But the problem is the assets look so different across all these different operators and all these different timescales that there really isn't a one size fits all approach. That's both a curse and a blessing, because it allows operators to do something that suits their asset base the best. I think your point is also well taken, that like there's a huge benefit of seeing across all these different instances. And that's something that we see all the time. We can understand like this whole case study on the pneumatics. Obviously, when we run into intermittent bleed pneumatics, it's something that I've spoken to other operators about, like, hey, you may want to measure this a little bit before you jump in. So do you think, as you look out 3, 4, 5 years in time, measurement informed inventories and having all these like bespoke emission factors company by company will have taken on more air, meaning that they will be a lot more accepted? Or do you think we're vectoring towards a world where obviously we're just going to go back to, we move from 13.5 standard cubic feet per hour to 8.8 standard cubic feet per hour on the pneumatics?
I think there's a world where everybody's moving towards measurement informed inventories, which is largely due to the point that you made around companies want to be making smart investment decisions. So if they have an avenue, and a well understood avenue, which I do think we have a year, 2 years to figure out really what's the best approach to getting to a true measurement informed inventory, is that this is where I need to be making an investment. This is where I will truly reduce my emissions. This is an opportunity for you to showcase that in your sustainability reports. You see growth and engagement on sustainability and ESG and being more transparent. So I do think that measurement informed inventories, regardless of where, maybe to your point on emission factors changing under federal regulations, I think that companies are going to start investing in trying to understand exactly what those emissions are, because it's what drives capital investment and ultimately reductions that they can advocate to the market that they are actually taking on. Yeah,
and it's an interesting dynamic of today versus tomorrow, because one of the pushbacks that I got when I was making this point to operators on the measurement informed inventories for these intermittent bleed pneumatics was like, listen, that's great that the emissions are not as much as what you think they are, but everyone is still reporting on subpart W, and for me, I can reduce my emissions dramatically just by going after these intermittent bleed pneumatics. The point that I say is some of these updated rules, truth does almost always play out. Now we can argue about the timescales there, but these updated factors do show that they will get it right over time. And I will say that those timescales will get more and more compressed, because there'll be more and more measurement and more research that's going on that will help shine a light when you have glaring discrepancies on something like this point that I keep coming back to on the pneumatics. So I think you're right. We will move to measurement informed inventories more and more with time. I do think that we are due for a follow-up to talk a little bit about the measurement and how you quantify these emissions and over what time scale, but we'll leave that for another time. Thanks for chatting.